I didn't prepare an official poll, but I did want to get a little bit of feedback from those of you in attendance, specifically around your experience with Fabric so far. So tonight I'm going to be talking about using data tools with Fabric. I'm going to start out with kind of a high-level overview, talking about the different ways that we can store data in Fabric, in one lake, which is the storage behind Fabric. And then I'll talk specifically about using SQL tools, namely SQL Server Management Studio, with lakehouses, warehouses, and SQL Database for Fabric. What I would like to ask all of you to do is go to the chat and just chat very briefly your level of exposure to Fabric. If you're new to it, if you're just aware of Fabric but don't have experience, tell me that you're a novice or you haven't looked at it yet. If you use Fabric all the time, let me know that, if that might be introductory or moderate, or if you live inside Fabric like I do, let me know that as well, just so we can kind of get an idea of where everybody is with the Fabric SaaS platform. So if you wouldn't mind just kind of throwing that out. Anything is okay. Not everybody uses all of these products. And I'll just glance at the chat as I'm doing my introduction. But my name is Paul Turley. I actually was one of the longtime leaders of the Oregon SQL SQL Server group. Arnie Rowland had started that group. Vern Robbie was one of my colleagues way back in the day, and we co-led that group. So I've been in the Portland area. I grew up in Vancouver, Washington. I live in Battleground, which is where I am now, but longtime member of this community. I've been pretty immersed in the Microsoft data warehouse and analytic reporting space for most of my career, which has been 25 plus years. I've been kind of honored to be part of the Microsoft MVP program for 16 years now, specializing initially in reporting services, analysis services, SQL Server, Power BI, and now Fabric. So it kind of followed that journey of the Microsoft BI platform kind of throughout my career. I've been with 3Cloud for 7 years now. I went to work. I was an independent consultant for a few years, went to work for Pragmatic Works about 7.5 years ago. Pragmatic Works was acquired by 3Cloud, and 3Cloud was just acquired by Cognizant. So we went from about 60 employees to 1,200 employees. So a month ago, Mike and I worked for a company that had 1,200 employees, and now we work for a company that has 340,000 employees. And we're really excited about that, aren't we, Mike? So you don't have to comment. But so I'm in a role in delivery engineering. Actually, we've just renamed our little group within our data and AI practice. So I now work in a group called the Emerging Technologies group. We're an internal support group. We do kind of pre-sales with customers. We support our architects and our consultants internally, but my role within 3Cloud is the Microsoft Fabric capability owner. And that means that I spend a lot of time with Microsoft product teams and our partner community, and it's my job to kind of keep up on our capabilities with Fabric and both promote that and support folks internally. And so I work with Fabric every day. Both on client projects and internal projects, demos, and do a little bit of training as well. So what are we going to talk about? So I'm going to start with a high-level overview of how data is stored in Fabric and how that relates specifically to using T-SQL and SQL Server-like tools. So you're going to see that Fabric really embraces the Microsoft data platform, but it is also the culmination of a number of different technologies like Spark and PySpark and Jupyter Notebooks. But we're going to kind of see where the SQL Server legacy is also part of Fabric. And Microsoft have now introduced and released, generally available, an instance of SQL Server, SQL Database for Fabric within the Fabric software as a service platform. So I'm going to iterate through those things. We'll talk about OneLake and Delta Storage. We'll talk about warehouses, lakehouses, and SQL databases, and then talk about how to use SQL Server tools, namely SQL Server Management Studio, with all of these storage objects within Fabric. I'll talk about the SQL endpoint and some compatibility considerations. And then I'm going to walk you through a demo solution where I'm using SQL Database with a warehouse and with a lakehouse to kind of stitch it all together. So let's just start by talking about this concept of OneLake and Delta storage. So I'm looking over the chat and I see that for the most part, most of you are saying that you have had a little bit of exposure to Fabric, some not so much. So I'm going to keep this high level, but I promise that I'm going to go a little deeper, and we're going to talk about practical uses and actually how to do things within Fabric. So this isn't going to be all intro. It's just going to start that way. So what is OneLake? If you are familiar with lakehouse technology, specifically if you've worked with in any of the cloud platforms, AWS or Google or Oracle or Azure, you're familiar with the concept of a data lake. It's a place to put anything you can imagine. Files, unstructured data, non-structured data. Within the Azure ecosystem, we have Azure Data Lake Storage, and the most modern way to store data within Azure Data Lake is with Gen 2 storage or blob storage. And what Microsoft did is they took Azure Data Lake Gen 2 storage and they put that behind the Fabric service and they called it OneLake. So when you light up a Fabric tenant, and so if you don't have anything and you just go to fabric.microsoft.com or powerbi.com and you start a tenant, you essentially have provisioned an Azure Data Lake Gen 2 storage behind the scenes. Now, you don't manage that in the Azure portal. It's just there. And we call it OneLake. And that is a common place for you to store everything in Fabric across all of your workspaces, all of your capacities, anywhere within your tenant, you have that blob storage. And you can store literally terabytes and petabytes of data for virtually free. It's you get a certain amount of storage for free, and then I believe it's 2.3 cents per megabyte per month after that. It's really dirt cheap to store data within Fabric. So that's what OneLake is, but the native way that data is stored behind a lakehouse, a warehouse, or even SQL database is in Parquet Delta format. And you don't have to know Parquet. You don't have to understand Delta. Just know that there is a common storage format to manage all of this structured data behind these objects. So what does Delta give us? Well, Delta gives us, or what we call Delta Lake, ensures ACID transactions, schema enforcement, versioning, all of that magically takes place. We can even do what we call time travel, meaning that as data is inserted and updated and deleted in a lakehouse or a warehouse, we can actually frame that data and say, show me the data as if it were 3 months ago. I want to see that snapshot of my data. and the Delta logs over Parquet files magically make all of that possible. Now, we're not going to get into the weeds of Delta, but we're going to just acknowledge that exists behind OneLake. All right, so how can we store data? Now, I did mention in the abstract of this presentation another storage container that I'm just going to acknowledge, but we're really not going to talk about, and that is a KQL database or an event house database. So we really have 4 different ways that you can store data. There are more ways that we can do that. Fabric actually encompasses Cognos DB and in preview PostgreSQL. But the native storage objects behind Fabric are a lakehouse, a warehouse, and now a SQL database. So what is a lakehouse? A lakehouse is the lightest weight storage container. If you have a bunch of data and need to store it in either unstructured or structured format, lakehouse is typically where we start. And when we build medallion architectures, which is typically the way that we would move data into a warehouse, we will typically use a lakehouse for our bronze layer, perhaps our silver layer. There aren't strict rules around these things. You could just build the whole thing with a lakehouse, but typically the less structured data belongs in a lakehouse. Why? Because it's cheap, it's easy to manage, it's easy to move in and out of, and it natively works with Spark, which can be very, very fast and fairly inexpensive when we ingest and transform data. A warehouse I'll talk about, but a warehouse is based on the SQL Server Database engine, but it's really designed for warehousing, for reporting and analytics, as opposed to transactional processing. And then we all know what SQL Server is, and I'm going to introduce SQL Database for Fabric a little bit later on, but that's our OLTP store, which is the newest member of the Fabric storage family. So what is a lakehouse? Combines data lake flexibility with SQL querying, supports Spark, notebooks, Delta tables, and it's ideal for data engineering. I'm going to demonstrate this, so I'm not going to spend a lot of time on slides. By contrast, a warehouse is for very structured data. It's optimized for analytic workloads, and you natively use TSQL with a warehouse. You typically don't use the Spark engine. You don't use PySpark. You don't use notebooks against a warehouse. It's not to say that you can't, but the native language and the native interface for a Fabric warehouse is SQL. It's decoupled storage. It is scaled out, and I'll talk a little bit more about the architecture of a warehouse here in a couple more slides. It's designed to be the backend for BI, and I'll talk about that as well. And then finally, SQL Database for Fabric is a fully managed transactional SQL database. SQL Database for Fabric is literally an Azure SQL managed instance. That's what's going on behind the scenes. So if you've worked with Azure SQL databases, or if you've worked with managed instances within Azure, this is going to be very, very familiar to you, because behind the scenes, that's exactly what it is. But underneath the MDF, LDF, NDF files and all of the guts of SQL Server storage, that data actually gets replicated down into Parquet files managed with Delta. But that's all behind the scenes. Okay, so let's think about, we need SQL Server. I just realized that this slide builds. And I don't think that worked. Yes, it does. Okay. I started to set up animations in this slide, and it just occurred to me that I hadn't finished. So I'm just going to build the whole thing out. So we think about I want to store structured data. I want to store OLTP data, transactional data. You've got some choices, and there are a lot of choices. So if you are familiar with SQL Server, if you have a background with the on-premises SQL Server product, as I do and Mike does, you know that there are several different editions of SQL Server. This takes us, for those of us who mainly work in the cloud these days, kind of takes us back in the day to where you would sit down in front of a computer. And I remember when we had stacks of floppy disks and would install SQL Server with, 15, 20 floppy disks, or a CD, now with a DVD image, but several different editions. The SQL Server engine has been around for a very, very long time, since the mid 90s. Then we kind of graduated to SQL Server on virtual machines. And, so you can install SQL Server or use a templated VM in the cloud with SQL Server pre-installed on it. Then we graduated to SQL databases in Azure. So today you can go to the Azure portal and just light up an instance of Azure SQL Database, and it's completely pre-configured, and you don't have to install anything. And then there are other flavors of SQL Server that exist within Fabric. There are also lightweight versions of SQL Server, and I'll just acknowledge that you've got SQL Server Edge and SQL on Azure Arc, and there are lots and lots of flavors of SQL Server. This is what we're going to be talking about, the Fabric Data Warehouse and Fabric SQL Database. By the way, there's confusion around the name of the implementation of SQL Server and Fabric, because before they released it, they referred to it as Fabric SQL Database. And then when it went to public preview in the fall, marketing decided to call it SQL Database for Fabric. So I still trip over that as I refer to this. So if you hear me saying Fabric SQL Database, that's because that's what I became accustomed to calling it. All right, let's focus a little bit on Fabric Data Warehouse, and then we'll dive into some demos. So back in the day, long time ago, when large organizations needed to build large-scale data warehouse solutions, SQL Server was kind of seen as a fairly lightweight transactional database. But a company called Data Allegro took the code base, so they worked with Microsoft to get the SQL Server code base, and they took that code base and they applied parallel database architecture to it, working with Microsoft. And a lot of this was based on research that David DeWitt's group at the University of Wisconsin in Madison did. They also worked with the California Institute of Technology, which also co-developed Teradata. Long story short, they created an appliance version of SQL Server that became known as the Parallel Data Warehouse. The Parallel Data Warehouse, which was offered by Data Allegro, a Microsoft partner based in Aliso Viejo, California, essentially sold hardware appliances with this special version of SQL Server pre-installed. And there were 60 separate network nodes that distributed the compute and then used central storage. Microsoft bought Data Allegro. They took that appliance-based version of SQL Server and they made it available as Azure SQL Database. Azure Data Warehouse. And then Azure Data Warehouse has since evolved into Fabric Data Warehouse. So that's the legacy behind Warehouse. So if you're familiar with any of these earlier incarnations of the Warehouse version of SQL Server, that's exactly what Fabric Data Warehouse is today. So, little history lesson there for whatever that's worth. Let's jump into some demos and we'll start talking about how to use SQL tools. So, thank you, Mike. I appreciate your vote of confidence there. I'm going to pause right here and just ask if there are any questions so far about how we got here. And with that, I'll share my screen. All right, now I am sharing a wide aspect monitor, and that might be a little small for some of you, but I will make a point to zoom in where I can. I'll just kind of explain my demo environment here. So this is a browser window, and I am signed into my Azure tenant. As you can see, it says Power BI up at the top, and I'll talk about that really quickly, why that says Power BI, and I'm talking about Fabric. And I have my browser window docked here to SQL Server Management Studio, and we'll transition over to SSMS here pretty quickly. All right. So within Fabric, Fabric is a tenant. You do everything in the web browser for the most part. But we're going to talk about using SSMS as well. But we provision a tenant in the web browser. You purchase capacities in the web browser. You create workspaces in the web browser. You navigate among workspaces. So what is Fabric? Fabric is a software as a service platform. It includes a lot of components that used to be available only through the Azure portal, where in Azure you would go light up services like Azure SQL Database or a lakehouse, and dozens and dozens of other services. All of those things are available in this SaaS platform now. So we have workspaces. Workspaces are the containers that I work in. I've created a workspace called MDF Uberlite. MDF stands for Metadata Driven Framework, and I'll show you why I gave it that name, because I'm going to show you a very, very lightweight, very simple metadata-driven data transformation or ETL or ELT framework. That's why I call it Uberlite. But these are what we call task flows. It's just a visual way of organizing all of my objects. I've got my storage objects right here. These appear to be containers, but they're really just very, very graphical kind of filtering things. I can also look at all of my objects by just clicking outside of one of these tasks. So these are my storage objects. So I have a lakehouse here. If I wanted to create a lakehouse, I'd just go up to New Item. And I just search among all of the different items, and I would choose a lakehouse. I would create the lakehouse, and it'll provision a lakehouse in, oh gosh, 10 seconds. And that's pretty consistent with the dozens and dozens of objects that I can create in Fabric. If I want to create a SQL database, I go add a SQL database, I give it a name, and that database is then available within seconds. So here's a lakehouse that I have created that I've called LH_bronze, which suggests that I'm going to use a medallion architecture. This is going to be a very, very lightweight medallion architecture, but the purpose for my bronze layer is essentially so that I can land my data in unstructured form. Now, purists would say that we use a raw layer for that. We may pull things into raw and then move them into bronze. And then I would start cleaning up my data, renaming objects, applying data types, maybe deduplicating and making corrections along the way. And so I would move that data from raw to bronze to silver and then to my gold layer, which is where I dimensionalize the data and prepare it for reporting and analytics. So bronze is the place that I'm going to start in this very lightweight demo. Now, my source data are all CSV files, and those files actually exist in an Azure Data Lake storage container, not within Fabric. Rather than importing copies of those CSV files, I've created shortcuts. And This literally, you can see the little shortcut icon right here to my airline stats blob container. And there are some folders in here that contain these CSV files. So what I want to do is I just want to bring in a copy of this, this comma separated data into structured storage in my bronze layer, and then I'll start pumping it through my medallion architecture. So if I just want to do that one time and keep things nice and simple, what I can do is I could come back to my workspace, and I can create a pipeline. Now, these pipelines really aren't going to do anything other than just copy these files from CSV, comma separated format, into structured storage and turn that into a Delta table. And again, this just because this is going to be a very, very simple demo. So you can see that this copy data activity within this pipeline has a source. So I have a connection that I've established. That connection actually represents the storage container, which has an object ID. It represents the workspace. It has an artifact ID. It has an endpoint. And so that connection is actually a bunch of GUIDs, and I'm going to show you what's behind that. And then I have a path. So this is my file path. And then I have the name of the file. So that's all metadata that's necessary to identify the source. And I designate that that's delimited text. And then my designation is going to be structured storage within this lakehouse. And I'm saying I want to create a table in a DBO schema in this lakehouse. It's going to create a Delta table with that name. And I'm just going to overwrite that table. And so if I were to run this pipeline, that should just take a few seconds to run because these are relatively small files. If you're familiar with Azure Data Factory, this will be very familiar to you. Queues everything up. I don't have any dependencies, so these will run in parallel, and it's just going to ingest those CSV files. And if the Delta tables don't yet exist, it will create them, and it's overwritten all of my data, and I now have that data in my lakehouse. So let's go take a look at the lakehouse. So here in my lakehouse, this is my structured storage. These are Delta tables. You can see the little Delta icon. And I can just click on a table and preview that data, but I'd like to query the data. So I'm going to query my airport table. And to do that, rather than just using this view, and I need to explain what we're seeing right now. Since I just ran that pipeline, essentially what I've done is I've overwritten all of the data, and it takes a little while for that metadata to keep up. And so that's why we're not seeing any data yet. I shot myself in the foot by running that pipeline. All right, I'm going to query this table rather than sitting and waiting. So in order to run a query, I can't query the Delta table directly. I don't have a means to do that. But what I'm going to do is I'm going to switch over to my SQL Analytics endpoint. What is the SQL Analytics endpoint? The endpoint is a very thin, call it a SQL Server query engine that sits over the top of the Delta storage. And so you're actually interfacing with a very, very thin, call it an instance of SQL Server, but it's extremely lightweight. And its only purpose in life is to let me run select queries. I can create some very lightweight objects, like I can create views, but you don't use it to manage security. You can't create tables. You don't create indexes. It's only for querying. But much like in SQL Server Management Studio, I can navigate through my schemas in my tables, and I can create a query. And I have some very lightweight IntelliSense here, but I can say, if I can type select star from DBO dot, and much like with SQL Server Management Studio, I can just run some very lightweight queries. And of course, it would be best practice to say top 100 if I'm going to do a select star. And I can run that just like I can in SQL Server Management Studio. If I have multiple queries, then I can highlight a query. And so we have some fairly nice tools here in the browser, but we can do better than that. And so what I'm going to do is I'm going to go up to my properties for the lakehouse, and I'm going to grab the SQL endpoint. The SQL endpoint is a web service address. I can copy that to the clipboard. Let me just jump over and actually did this a little bit earlier. I'm going to paste that. I think that will be the same address. And I just want to point out that in the web service address, it's identifying this object as a data warehouse. So this is what the SQL Analytics endpoint does over a lakehouse, is it essentially lies to my client tool and says, hey, I'm a data warehouse. And so I'm going to exhibit all of the characteristics of a Fabric SQL warehouse, which is the same thing as an Azure data warehouse. And so with that on my clipboard, I can jump over to any client tool that knows how to connect to SQL Server or a Microsoft data warehouse, and I can paste that right here. Now I already have my connections cached, so I'm not going to do that. But just by creating that connection, let me do this. So there's my data warehouse endpoint, or my SQL Analytics endpoint. Notice that I have the database name selected here. Because these addresses are a little difficult to read, and at a glance, I can't look at that server name and really recognize exactly what it is. For that reason, they've given us some nice tools in the newer versions of SSMS. You can color code your queries. So I'm going to color code that with gold, which suggests that that's my gold layer, or orange, I guess. And then I can connect to that. So let me go over to a query window. And open up that connection. Now remember that we started with a lakehouse. So I grab the endpoint. That endpoint literally is a server. So if you think about the way that you connect to SQL Server, you have a server, and then you have a catalog item. A catalog item typically is a database. But as I expanded the wrong thing. As I open up that server or that endpoint, you'll see that I actually have multiple catalog items or databases here. Each of my lakehouses is a catalog item. My warehouse is a catalog item. But look at this. My SQL database is also a catalog item. And I'm going to kind of put a pin in that, and we'll come back to this. So I can query my SQL database for Fabric through the SQL Analytics endpoint, or I can query it directly through the SQL Server connection as well. And I'm going to come back and talk about that. Let's just take a look at the bronze lakehouse. So here we see our tables, and you can see that I can query any of these tables just like I could with SQL Server. Now, as I said, you can run select queries, you can create views. Indexes are not a concept that applies to lakehouses or warehouses for that matter. Data is already in optimized, read optimized form. There's no need to index it. There is no need to optimize it. You do not define primary keys within a lakehouse. We can in a warehouse, but we don't define relationships. A lot of those things just kind of go out the window because of the way that Parquet Delta pre-optimizes this data for fast reads. All right, any questions so far? All right, let's jump back and talk about warehouses now. So I'm going to go back to my workspace, go back to storage. So I have a bronze lakehouse. You can see there that I've just brought my essentially my files in as structured tables, but the data types are all text. I haven't really optimized this at all. In my silver layer, my goal is to rename my objects so they make a little more sense. You can ignore these tables down here. That was kind of old work. But so I'm using more intuitive names, but I'm also going to change data types. So if we go and take a look at we'll take a look at this date dimension table. You can see that I've made a point to use correct data types. There's a date data type. Here's an integer. I'm using text in a few different places. But again, because the Lakehouse stores data in Delta Parquet format, my data types are defined by the rules of Delta and Spark rather than SQL Server, but we're using compatible data types. So my goal now is to move from bronze to silver and to start cleaning up the data, typing it, and giving it more intuitive mixed case column names. And then we're going to move to our warehouse. So here is my warehouse. So if you have a SQL Server background, this is now more familiar territory. We manage things that are schema bound. We can create objects using create table, we can create stored procedures, user-defined functions. So this is going to be more familiar territory for SQL Server professionals. But because it's based on Azure Data Warehouse rather than Lakehouse, rather than SQL Server, we typically don't define relationships. We don't create indexes. You don't have to worry about whether the data is clustered or non-clustered, because all of that is optimized for reads. And generally speaking, you don't have to optimize storage for your structured data. Now, how would I move data into a warehouse? Well, I would typically use stored procedures rather than PySpark notebooks. And let me just go back and kind of speak to that very quickly. To move data between my files in bronze layer, you can see that I used a pipeline, and my goal is to use a metadata-driven pipeline where I store all of my metadata in a table, which is what I'm going to use my SQL database for. But to move data between lakehouses, I'm typically going to use Spark notebooks to do that. So let's take a look at some very simple examples of Spark notebooks. Here I'm just lifting data out of those bronze tables that you saw earlier, moving them into my silver tables. In a more complex solution, I would change data types, and I may do some grouping and some cleanup and deduplicating. You can see that here I'm moving data into this bird strike table that's less structured. In this cell, I'm creating my date dimension table, and I'm actually just manufacturing that table using Python-based code. The purpose of this presentation is to not walk you through PySpark, but I'm just showing you how notebooks are typically used with lakehouses. But that brings us to using stored procedures with the warehouse. So we've created our SQL endpoint, and now I'm going to define my tables. And we'll do this in much the same way that I would with SQL Server. So I'm just defining my table, drop table if it exists. Here's my table. It's strongly typed. I'm using intuitive column names. But you can see that I'm not defining any constraints. I'm not defining indexes, as is the case with the warehouse. You typically don't need to do that. So I'm defining all of my tables here, and then I'm going to create stored procedures that I'll use to populate those tables. Now I'm keeping things nice and simple. So for each of my insert stored procs, I'm just going to delete and then insert, but we could use merge statements and use watermarks and date ranges and things like that. All right. So there are our stored procs. Now, so we've talked about using the SQL Analytics endpoint so far. And so you know that you can use the web editor in the browser, or if you prefer to use a more evolved tool like SSMS, you can run all of these scripts within SQL Server or within SQL Server Management Studio, just like you would with SQL Server. So let's graduate to SQL Database for Fabric. And I'm going to go back to my browser. Let me just close all of the objects that I have open so far, just to clean things up. So I've created a SQL database for Fabric. And again, I would do that simply by going to a new item. Here's SQL Database. SQL Database went to general availability just late last year in November, I believe. It was in public preview for about a year before that. So this is a pretty new member of the Fabric family, but it really just as easy as clicking this button and giving it a name. So I'm going to open up this editing tool and management tool, and you can see that I can switch to the SQL Analytics endpoint, which would really give me the same address that I got from my other objects. But rather than doing that, I'm going to go to Properties. You can see that there is no endpoint here. And the reason for that is the way that we connect to SQL Server for Fabric is a little bit different than the way that you may be accustomed to connecting to SQL Server. And so if you look at the connection string, you'll see that there is a server address, an endpoint address right here, and that the object is identified as a database, but the catalog item has this big old ugly name. So the endpoint identifies my database with a short, friendly name. That's because it's scoped and managed within the workspace only. So it's the endpoint is confined by the workspace. Because Microsoft needs to globally identify the name of this database, they tack a GUID to the end, and that is your catalog item, and that's what you're going to see in SSMS. So I need to grab the entire connection string, and that's how I'm going to connect in SSMS. So I go to Database Engine, and again, I've already created these connections and saved them, but here you can see that I've pasted the entire connection string. And if you go to the connection properties, you'll see that there's the server name that we saw earlier, and there's that big ugly database name. Then I make a point to give it a color so that I get a clue as when I have multiple query windows open. Another thing that I like to do is use the registered servers feature within SSMS. Now, this is a feature that's been around for a long, long time. I believe that I learned about this when Rob Beck, a longtime member of our user group, did a presentation many years ago on using registered servers. And this is something that DBAs will typically use when they're managing a data center or lots of different servers. But essentially what you're doing is you're creating shortcuts to SQL Server instances, and you're saving the connection information inside of a named property. And so something that I like to do is I'm working with multiple clients and working with different environments. So SSMS lets me save my connections now, which is nice. So I'm going to use the SQL database to manage my metadata-driven framework. So what is that? Well, essentially, what I want to do is I want to automate my ETL process. So rather than building a pipeline that has hard-coded connection information and hard-coded file names and hard-coded table names, I want to drive all of this using metadata that's stored in a table. And we have MDF frameworks that we use at 3Cloud that are very complicated and have many, many layers and do a lot of lookups and use stored procedures with notebooks. And rather than showing you something that's very, very complicated that we use in production, I'm just going to show you a very simplified version. Essentially, I've taken that same pipeline that I showed you earlier with the copy data activities, and I'm going to do a lookup using a stored procedure and get a list of all of the keys for records in a table. And those represent copy data tasks. And then for each of those copy data tasks, I have source information and destination information that represent my files and the tables that I want to insert them into. So I'm going to pass a list of keys to a for each file task. And then for each key value, I'm going to pass that into a lookup. I'm calling a stored procedure. I'm passing to that stored procedure the task ID. It's going to do a lookup, and it's going to give me an entire row, all of the column information that I'm then going to map to the properties of my source and my destination. Now, just for demo purposes, I'm only getting the file path and the file name and the table schema and the table name. In a production solution, I would go get the workspace ID, I would go get my connection information. There's all kinds of things that I can dynamically set, but I'm just going to keep this nice and simple. All right, so how do I manage this? Let's go back to SSMS. Essentially what I did is I went to the original pipeline that I built, and for each of those activities, I'm going to look at the JSON definition and get the property values that I need to set dynamically. So here I have my folder path. Here I have my file name. Again, in production, I would go get the workspace ID, the artifact ID, and other information. And then in the sync or destination, I have the schema and the table. So for demo purposes, that's the only thing that I'm going to manage. And so I've just built a table with those property values as columns, storing them as text as varchar 200s with a task ID for each. And then I'm going to populate this table with that information. So you can see the table down here, my folder paths, my file names, schema names, and then the output file names. And finally, let's go run this. And just before I do that, I'll show you the stored procedure that I use to pass that task ID. So there's my task ID right there. I'm just passing the task ID in, and it's just going to return that record. Real simple stuff. And that stored proc is called right there. All right, let's run that. And this will be very exciting as we'll see it looping through each of those file to LH table activities and doing the lookups. And, if we wanted to look down, under the hood, we could go look at the input and output values. But just like a Christmas tree, you can see that the status will change from blue as it's queued up to green as it's successful. And if we had any failures, then you'd see the red X, and then you could go investigate that. So let me jump back to my slides and talk a little bit about use cases for SQL database for Fabric. So stop sharing my screen and just jump back to my slides. All right. And just to back up and review just a little bit. So as we were querying the lakehouse in SSMS, in order to do that, I go through the Fabric SQL endpoint. You have two different ways of talking to Delta storage in a lakehouse. One is through the SQL endpoint, which is this thin querying layer. It sits over an execution engine. That execution engine is actually Spark. So Delta is always orchestrated with Spark. We have Spark clusters that sit over the top of that one lake storage, and Spark is the layer that's always used. The SQL Analytic endpoint talks to the Spark engine, which in turn talks to the Delta storage. There is also endpoint object storage. So if I were to create a view in SSMS when connected to the endpoint and a lakehouse, that view persists, but it is not stored in Delta storage. It's stored in private storage that is associated with that lakehouse. It's kind of the magic of the endpoint. Same thing with the warehouse, but there are limitations to these things. So if I'm using a lakehouse with the SQL endpoint, you can run select statements. You can create some very lightweight objects like views. You can use that for BI reporting. You can connect through the endpoint with Power BI. You can connect with Tableau or any other reporting tool that knows how to talk to SQL Server. You can use that with very large volumes of data, and it's going to scale and it's going to run very quickly. Fabric Warehouse is intended to be familiar to SQL folks. And in Fabric Warehouse, you have the SQL, the only way you talk to a Fabric Warehouse is through the endpoint. And you can do inserts, updates, deletes. We don't have indexes, and that's a good thing. That's why I made the X green. You don't have to create indexes. There is no need to create indexes, which kind of goes against the grain for most SQL Server folks to think, wait, I need to optimize this thing. It's already been optimized for you. You can create temp tables. They work a little bit different. They are session scoped. You can create them as distributed or non-distributed, meaning that it either works across the entire cluster or it just works within your session. The warehouse is not for OLTP workloads. If you're doing a lot of inserts or a lot of updates, they're going to be slow. That's not what the warehouse is all about, but it's intended to be high volume. For SQL Database for Fabric, it's not intended for high volume workloads. And this is not going to be the optimal tool for you to use if you have a very busy web application. Fabric Data Warehouse or SQL Data Warehouse, I'm sorry, SQL Database for Fabric is not going to be the optimal choice for a busy web front end or a busy application. Why? Because it sits on top of a fabric capacity, and it really runs at one speed. You don't have levers that you can change. You can't scale it out or scale it down at will. You can scale your capacity, but you don't have control over the database itself. And the fact of the matter is that there are more cost-effective ways to light up SQL Server than within Fabric. If you need a small database to manage something like a metadata-driven framework, like what I just showed you, or you need to manage fairly lightweight reporting data, SQL Database for Fabric is a very convenient way to do that, but I wouldn't do it with a billion rows of data. All right, question time. What questions do you have about when you would and would not want to use SQL Database for Fabric? This is what they call in Toastmasters the 8 seconds of uncomfortable silence, because I'm expecting people to ask questions.
Are those new glasses, Paul?
These are my computer glasses.
Oh, okay. Very nice.
Yes, yeah. See, these are my regular progressive lenses.
Right.
Is that the best question you could come up with, Mike?
Well, you wanted a question.
I wanted a question about SQL Database.
I'm just enjoying this. It's a good presentation, and it's nice to see that all of this has become a reality.
Yeah.
It fixes a lot of problems.
Yeah.
So it just makes it more useful. I mean, that's the whole thing. The idea of a platform. I mean, Microsoft has been promising that this was going to be the one size fits all platform, and now they're actually making it do that. So that's great.
All right. Gary has a question. Thank you, Gary. How does the connection and integration work with Power Platform work? Is the Dataverse separate or integrated into Fabric? Dataverse is not an integral part of Fabric. There and I have very light experience blending Fabric with Power Platform. There is an optimized connector for Dataverse, and I'm readily admitting that I don't have a lot of experience with this, but I believe that it uses Fabric's mirroring technology to shortcut to Dataverse and or mirror the data from Dataverse for integration purposes. I will say that I'm not exposed to many projects. A couple of weeks ago, our Power Platform folks reached out to me for some support on the Fabric side. But I was reading a lot of Microsoft Learn documents to work through that. So that was relatively new to me. I think that we're going to see a lot more collaboration between product teams at Microsoft, specifically, the M365 and Power Platform and Dynamics groups that are kind of represent the facet of Microsoft that you're describing, and Fabric, but I think a lot of that is still forthcoming. Yeah, so Fabric has its own storage medium, and that is one lake that utilizes Delta Parquet, but we have connectors for just about anything you can imagine, including Dataverse.
Hey, Paul, I have a
Jeremy.
question.
Yeah.
So what is kind of an organization's deciding point on moving over from building objects in the Azure portal to moving over to Fabric?
Good question. And I have lots of answers. One is that, first of all, if you look at all of the capabilities within Fabric, a lot of those capabilities, and you've been along for the ride for the past 3 years as we've been adopting and building solutions in Fabric. Um, a, a lot of the mechanisms within Fabric, and particularly those that were part of Fabric's inception. Data factory pipelines, notebooks, lakehouses, where, all of those things that were really core to Fabric were plucked from Azure services. Those product teams that used to roll up under Synapse Analytics and Azure now all report to the Fabric product leadership, which is very telling. So innovation is going to happen in Fabric.
Yeah.
Maintenance is going to happen in Azure. So we're going to see features added to Azure, and they'll be supported for a very, very long time because there is a very good story for Azure developers, and I think that deep product engineering still happens in Azure because it's IT facing and it's developer facing. Fabric is a platform that is IT facing, but it is more business facing. It's supposed to be convenience first and then deeper functionality secondarily. So it's hard to say that everyone should leave Azure and run over to Fabric because that's not entirely true. But the innovation is going to happen here. And the bottom line, and you're not going to see this in Microsoft marketing material, is that if this is the profitable thing for Microsoft, that's where they're going to make their investments. And
Yeah.
this is the profitable thing for Microsoft.
That makes sense.
Yeah.
And have you run into any gotchas as you've migrated objects from Azure over to the Fabric environment?
How much time do you have? Well, yeah. I mean, as we get out of the mainstream and start dealing with oh my gosh, I mean, there are hundreds of examples of uh, features of Azure Data Factory that haven't made their way into Fabric pipelines yet.
Yeah.
But product teams have been feverishly working on that for the past 4 years. Yeah.
Okay. Cool. Thanks,
Yeah.
Paul.
Yeah, you bet. What I think one thing that is very telling is that if you look at the Microsoft leadership, so there were two gentlemen who were primarily responsible for the advent of Fabric. They are Amir Netz, who is the technical fellow and the visionary behind the platform, and Arun Ulag, who was the vice president, reporting to Satya Nadella, who essentially made Fabric happen organizationally. Arun has since become the senior vice president over the entire data platform at Microsoft and still owns Fabric. And what that tells me is that the person responsible for Fabric is now responsible for the entire data platform. Therefore, Fabric is a winner, and that's where the investment's going to happen.
Makes sense.
Yep. All right. As Fabric is not yet available for the government cloud environments yet, are there resources you might recommend? Oh gosh, that is a really tough question, Stevie, and I don't have a real good answer. Every time the question comes up in partner meetings and MVP meetings, and those meetings that we have facing the product teams, what they say again and again and again is we're working on that. I don't have a better answer than that. I think that the first thing that the product teams took on was EU compliance, and the compliance standard is escaping me right now, but the the standards enforced by the EU, and in making sure that services are contained within regions. It took them a little while to make all of Fabric work for European clients across all of the European countries. That was their first priority, simply because it represents a large market share. And I know that they're working very, very hard on the government cloud for Fabric. All right. Well, that is what I have to present to you this evening. You're welcome to stick around and ask more questions if you have them. As you can tell, this is a fairly new presentation, and so I'm just kind of skipping through some slides. But you're welcome to reach out and connect. I do some light project work on the side, and so if you do have opportunities, or if you're looking for some support with Fabric or any of the things that we've talked about, reach out to me for that reason. But if you have questions, you're welcome to reach out to me as well. Sign up for my blog. I do blog pretty frequently about Power BI for the enterprise and Fabric topics, and you can reach me on LinkedIn as well.